Okay students, today topic is distributed query processing. Distributed query processing, okay. Query processing is the activity performed in extracting data from the database. In query processing, it takes various steps for fetching the data from the database. You just imagine you are ordering a pizza in online. So how does the system know which restaurant has the ingredients, calculate the price and gives you an estimated delivery time? Okay, so you can relate this to distributed query processing. Okay, so why? Because here retrieving the information from multiple databases like multiple restaurants efficiently, right? So once again I repeat, the query processing is the process of fetching the data you requested from a database. Query processing is the process of fetching the data you requested from a database. It's like asking a friend for a book. It is another one example. If you are asking a book to your friend and your friend goes to the multiple rooms to find it quickly. Okay, so these are the steps are involved in query processing. The first one parsing and translation, and second one is optimization, and third one is evaluation. Okay, so first one parsing and translation. So here the database first checks if your query is written correctly. Okay, it also translates. Here the database first checks if your query is written correctly. It also translates it into a format the system understand. Okay, so it also translated into the format the system understand. Okay, the example, suppose I can write as English in show all students who scored greater than 80. Okay, suppose I write in English as show all students who scored greater than 80. So here the database translated into an SQL commands like what? Select star from student, where the condition we have to apply, where marks greater than 80. Okay, suppose I have to write show all students who scored greater than 80. Here the database translated into SQL commands like select star from student where the marks greater than 80. Okay, and the next one is optimization. Here the database tries to figure out the fastest way to get the database. Okay, the before one, the first step is what? Database first checks if your query is written correctly, and second, optimization, the database tries to figure out the fastest way to get the data. Okay, it's like an planning the quickest route to deliver the pizza from multiple restaurant. Okay, so database can either scan all records or use an index to fetch the students with marks greater than 80. Before I given one example for the parsing and translation, right ma'am? So here optimization, here we could apply the conditions students with marks greater than as 80. Okay, and the last one is evaluation. So finally the database execute the query and returns the result to you. Okay, so evaluation is what ma? Finally the database execute the query and returns the result to you. So here SQL engine runs the query and gives a list of students who scored greater than 80. Okay, explain the same content as very briefly. Parsing and translation. As query processing include certain activities for data retrieval. Initially, the given user queries get translated in high level database language such as SQL. It gets translated into expression that can be further used at the physical level of the file system. After this, the actual evaluation of the queries and a variety of query optimizing transformation and takes place. This before processing a query, a computer system needs to translate the query into a human readable and understandable language. Consequently, SQL or structured query language is the best suitable choice for humans, but it is not perfectly suitable for the internal representation of the query to the system. Relational algebra is well suited for the internal representation of a query. The translation process in query processing is similar to the parser of a query. When a user executes any query for generating the internal form of the query, the parser in the system checks the syntax of the query, verifies the name of the relation in the database, the tuple, and finally the required attribute value. Suppose a user executes a query, as we have learned that there are various methods of extracting the data from the database. In SQL, a user wants to fetch the records of the employees whose salary is greater than or equal to 10,000. Okay. For doing this, the following query is undertaken. Select employee name from employee where salary greater than 10,000. Thus, to make the system understand the user query, it needs to be translated in the form of relational algebra. So, here we can bring this query in the relational algebra form as sigma salary greater than 10,000 or pi salary of employee table, or pi salary or sigma salary greater than 10,000 of the employee table. So, after translating the given query, we can execute each relational algebra operation by using different algorithm. So, in this way, a query processing begins its working evaluation. For this, with addition to the relational algebra translation, it is required to annotate the translator relational algebra expression with the instruction used for specifying and evaluating each operation. Thus, after translating the user query, the system executes a query evaluation plan. Okay. So, actually the concept of this parsing and translation is the first step in query processing. Already I told you, right? The system checks the query syntax and verifies the tables and column and convert the user query into machine friendly format. Okay. The system checks the query syntax, verifies tables and column, and they convert the user query into a machine friendly format. Okay. For example, you just think of SQL as English and relational algebra as a mathematical language, so that computers understand. Okay. Suppose, see here, select employee name from employee where salary greater than 10,000. Okay, wow. Which means, so this is an human readable, but the system cannot execute the SQL directly. Okay, it is an human readable. So, select employee name from employee where salary greater than 10,000. It is an human readable. Okay, it is an human readable, but the system cannot execute this SQL directly. So, it must be translated into relational algebra. It must be translated into relational algebra. Okay. So, here sigma, we could explain the both forms like an sigma salary. So, here the sigma means selection process. Okay, we have to apply the selection process, which means the condition we have to apply that get the salary greater than of 10,000 of the employee from an employee table. Okay. So, another one format is what? Pi. We could apply the pi. Okay, which means this is called as what? Projection. Okay. So, selection column, which means the selection column. Okay. So, it could select the salary more than get 10,000 from the employee table. Okay. So, here the parser would check the query syntax, so verifies the table name, attributes and the tuples and create the parse tree. So, it also replaces any views used in the query with the actual and underlying of tables. Okay, once translated into relational algebra, the system needs to execute the query. So this is called as what, ma? Query evaluation, right? Before I told you. Okay, so I would explain the flow chart of steps in query processing. So these are the steps are involved in execute the query. Okay, so the first one here, the query user can give the query. Okay, and the second step is parser and translator. So here the process starts when you use a submit a query. Okay, here only the process start when you use submits a query. So usually in SQL the query parser checks the syntax. Okay, here the parser and translator, the parser only checks the syntax and validate the table names, attributes, and ensures everything is correct here. Okay, so and another real time example, like a teacher checking a student's assignment for errors before put grading. Okay, so this is the first step. The process starts when you use a submit a query, usually in SQL. Okay, the query parser checks the syntax, validate the table names, attributes, and ensure everything is correct. Okay, and the next step is relational algebra expression. Okay, so here optimizer analyzes the relational algebra expression and finds the most efficient way to execute it. Okay, so whatever query we given already, here the relational algebra expression, they convert the queries into machine readable language. Okay, and this next step is the optimizer analyze the relational algebra expression. Okay, so before I told you that I given the two steps to fetching the data, right? Sigma salary and pi salary we given already, right? So this is the two ways to fetch the data, so of the same data from the employee table. Okay, so here only the optimizer will help you to find the fetch the exact data. Okay, the optimizer analyzes the relational algebra expression and finds the most efficient way to execute it. Okay, so like planning the fastest route on Google Maps instead of taking a random road, right? And the next one, statistic about data, which means here the system may also use a statistic about the data. So like number of rows, number of indexes, or distribution of values. So it will help the optimizer choose the best execution plan. Okay, so actually optimizer will help you get the exact way. Okay, but the statistic about the data means data about the data. Okay, the system may also use the statistic about the data. So like number of rows, indexes, distribution of values also here. Okay, so it will help the optimizer to choose the best execution plan. Okay, so here the optimizer choose the best plan. Okay, and the next step is what, ma? Execution plan. Okay, so here execution plan is the set of instruction, so that tells the databases how to perform each operation step by step. Okay, so once the optimizer is over, means the next plan is execution plan. The execution plan is set of instruction that tells the database how to perform each operation step by step. Because execution plan means we could follow certain procedures to complete the process, right? So here next one, execution plan. So here the execution plan is a set of instructions, so that tells the database how to perform each operation step by step. Okay, so here the scan the employee table, filter rows where salary greater than 10,000. So return only employee name of column, right? And the last one is evaluation, the next one is evaluation engine. So here the evaluation engine actually performs the operation from the execution plan. Okay, the evaluation engine actually performs the operations from the execution plan, fetching the data from the database. Okay, so like a chef following a recipe exactly to cook a dish, it is an example of evaluation engine. Okay, So, and the last step is query output. Here the result of executing the query is returned to the user at the query output. So, here we are getting the employee data whose salary getting more than 10,000 from an employee table. Okay. So, this is the steps in query processing. The cost of the query evaluation can vary for different types of queries. Although the system is responsible for constructing the evaluation plan, the user does need not to write their query efficiently. Usually a database system generates an efficient query evaluation plan which minimizes its cost. This type of task performed by the database system and is known as query optimization. For optimizing a query, the query optimizer should have an estimated cost analysis of each operation. It is because the overall operation cost depends on the memory allocation to several operations, execution cost and so on. Okay. Suppose if you have two routes to reach a destination, okay, one longer and one shorter. So, which one would you take? Similarly, when a database fetches the data, it can follow many paths. So how does it decide which path is best? Okay, so relate this to query optimization, choosing the most efficient way to execute a query. Okay, so the concept of query optimization is the process where the database figures out the best way to execute a query to minimize the cost, such as the time, memory and resources. Okay, optimization is needed. Okay, we know the concept of optimization and why we need optimization. Okay, yeah. So, different ways of executing the same query can have very different cost. For example, scanning the entire table is slower than using an index. Okay, so like choosing the fastest route on a GPS. So, even if the starting instruction is the same, the system calculates which route saves time and fuel. Okay, so that's why we need and the optimization process. And the last one is query evaluation plan. In order to fully evaluate a query, the system needs to construct a query evaluation plan. The annotation in the evaluation plan may refer to the algorithm to be used for the particular index or the specific operations. Such relational algebra with annotations is referred to as evaluation primitives. The evaluation primitives carry the instruction needed for the evaluation of the operation. Thus, a query evaluation plan defines a sequence of primitive operations used for evaluating a query. The query evaluation plan is also referred to as the query execution plan. A query execution engine is responsible for generating the output of the given query. It takes the query execution plan, executes it and finally makes the output for the user query. Okay, it is nothing but it is very simple concept. If you follow a recipe, okay, I will give one example. If you follow a recipe, you need step by step instruction to cook a dish. Okay, similarly, how does a database know exactly how to fetch the data for a query? Okay, so it just lead them to the concept of a query evaluation plan. Okay, so that query evaluation plan is a step by step sequence of operations so that the database follows to execute a query efficiently. Okay, maybe it included not just the operation but also how to perform them, like which algorithm to use for join or which algorithm to use for selection. Okay, so like a cooking recipe that tells you order of steps and techniques, right? First we could chop the vegetables first and then boil. Likewise, you just follow the certain process to cook a recipe. Okay, so here the relational algebra operations with the instructions are called as what evaluation primitives. okay, such as relational algebra with annotations referred to as evaluation primitives. The relational algebra operations with instruction are called as what? Evaluation primitives. So, these carry all the details needed to execute each operations. Okay. For example, already we seen that operations sigma salary greater than 10,000 of from the employee table, right. So, here the evaluation primitives use the syntax scan on salary column to filter the rows, okay. And the evaluation plan is also called as what ma? Query execution plan, and it tells the database how to execute the operations to get the result, okay. So, the finally query execution engine is the responsible for generating the output of the given query. So, here query execution engine takes the execution plan, performs all the steps and produce the final output for the user query, okay. So, it takes the query execution plan, executes it and finally makes the output for the user query. So, the example is what? Select employee name from employee where the salary greater than 10,000, okay. So, execution plan steps is the first one, scan the employee table, the first step, scan employee table, and second thing is filter the rows with salary greater than 10,000, and third, return only employee name column. So, the execution engine performs these steps and outputs the result, okay. Thank you.